In this module, we are going to discuss about query processing in database management systems. Also, we will discuss measures of query cost, selection operation, sorting, external sort merge algorithm. The main goal of creating a database is to store the related data at one place, access and manipulate them as when it is required by the user. Accessing and manipulating the data should be done effectively. That is, it should be accessed easily and quickly. But a database is a system, and the users are either another system or application or a person. The user can request the data in a language that he understands. But database management system has its own language which it understands. Hence, the users are asked to query the database in its language, that is SQL. This database management system uses this SQL language for communication. This SQL is a high-level language created to build a bridge between user and database management system for their communication. But the underlying systems in the database management systems will not understand SQL. There has to be some low-level language which these systems can understand. Usually, any query written in SQL is converted into low-level language using relational algebra, which system can understand. But it will be difficult for any user to directly write relational algebra kind of queries. It requires thorough knowledge of it. Hence, what database management system does is it asks its users to write query in SQL. It verifies the code written by the user and then converts them into low-level languages. It then selects the best execution path and execute the query and gets the data from the internal memory. All these processes are together known as query processing. So, query processing is the step-by-step process of breaking the high-level language into low-level language, which machine can understand and perform the requested action for user. Query processor in database management systems perform this task. Or we can define query processing as the range of activities involved in extracting data from the database. And the activities includes the translation of queries in high-level database languages into expressions that can be used at the physical level of the file system, a variety of query optimizing transformations, and actual evaluation of queries. When a database system receives a query for update or retrieval of information, it goes through a series of compilation steps called execution plan. The basic steps involved in processing a query are parsing and translation, optimization, and evaluation. And this is the figure which includes the steps involved in processing a query. Our first step is parsing and translation. Here in the steps, that translate the query into its internal form. This is then translated into relational algebra, and parser checks index and verifies the relations. The next step is optimization. The SQL is a very high-level language. The user specifies what to search for and not how the search is actually done. The algorithms are chosen automatically by the database management systems. For a given SQL query, there are maybe possible execution plans. Among the strong equivalent plans, choose the one with lowest cost. The cost is estimated using statistical information from the database catalog. The final step is evaluation. The query evaluation engine takes a query evaluation plan, executes that plan, and returns the answer to that query. So given a query, there are generally a variety of methods for computing the answer. For example, we have seen that in SQL, a query could be expressive in several different ways. Each query can itself be translated into a relational database expression in one of the several ways. Furthermore, the relational algebra representation of a query specifies only partially how to evaluate a query. There are usually several ways to evaluate relational algebra expression. Let us discuss the whole process with an example. Consider the query. Select salary from instructor where salary less than 75,000. This query can be translated into either of the following relational algebra expression. Each relational algebra operation can be evaluated using one of the different several algorithms. Correspondingly, a relational database expression can be evaluated in many ways. Annotated expression specifying detailed evaluation strategy is called an query evaluation plan or query execution plan. To specify fully how to evaluate a query, we need not only to provide the relational algebra expression, but also to annotate it with instructions specifying how to evaluate each operation. Annotations may state the algorithm to be used for a specific operation or the particular indexes or indices to use. A relational algebra operation annotation with instructions on how to evaluate is called an evaluation primitive. A sequence of primitive operation that can be used to evaluate a query is a query execution plan or query evaluation plan. And the figure below illustrates an evaluation plan of our example query. The query execution engine takes a query evaluation plan, executes that plan, and returns the answer to the query. The different evaluation plans for a given query can have different costs. We do not expect users to write their queries in a way that suggests the most efficient evaluation plan. Rather, it is the responsibility of the system to construct a query evaluation plan that minimizes the cost of query evaluation. This task is called query optimization.